Ladies and gentlemen, welcome at the 2018 Futures Technology Conference here in Vancouver, Canada. And next to me it's Mike Bernico. Mike works at StateFarm Insurance, and he's a lead data scientist over there and a true believer in the power machine learning has to change the world.
That's right.
Mike submitted a paper on the importance of the two factors of impact on the performance of transfer learning models. A, the size of the target data set, and B, the similarity in distribution between source and target domains.
Yeah.
Welcome, Mike.
Thank you.
Good to have you. Hey, what is transfer learning, and what can you achieve with transfer learning models?
Transfer learning is a really practical technique inside the domain of deep learning. And the idea is you can train a neural network on a source domain of data. And after you do that, you can take sort of the knowledge that's gained from that training process and apply it to a target domain. And by doing so, it allows you to learn something in that target domain using much less data than if you hadn't done transfer learning.
Clear. How does transfer learning compare to other methods of machine learning?
Well, really, transfer learning can be applied to all types of machine learning, including computer vision, which my paper was about, but also things like natural language processing. It can be used all across the domain. Really, transfer learning is a way to get to great results with just a little bit less data, or in some cases, a lot less data.
Yeah, cool. Hey, what is a real-life example of applied transfer learning applications, for example, in the insurance business, your business?
Yeah. Well, as you can imagine, it would be really nice to be able to use a photograph of a vehicle and understand just how damaged it's been.
Yeah.
Or, not necessarily just a vehicle, but also a house, any kind of personal property. So that's a really useful thing, but it takes a lot of data to get there.
Yeah.
And sometimes you don't have the data. Sometimes you do have the data, but it's not labeled in the way that you need it to be. It's not ready for machine learning. So transfer learning has been really important where I work because it allows us to get to a workable solution with as little data as possible.
Yeah. Hey, let's go to your paper, because in your paper you mentioned the similarity in distribution between source and target domains. What does this mean? Right.
Well, so one of the things that we learned in the paper is that as far as we can tell, more data always helps. But what we also learned is that when the source domain, the domain that you're learning from and transferring from, to the target domain, the domain that you're transferring to, if those problem domains are very similar, you can use less data, and if they're very different, you need more data.
Yeah.
So for example, if the source domain were general photographs of images, and the destination were maybe, is this image a cat or a dog?
Yeah.
That would require less data than if your source were something like people's faces and your destination was something like architecture of a building. Very different.
Yeah. Hey, to what extent can the findings of your paper be used to improve the performance of transfer learning models?
Well, I really see our paper as kind of a first start into looking around data volume in transfer learning. What I would love to see is someday, with some additional research, some heuristics become developed where we can say, given the problem that I need to solve, here's about how much data I need to solve it. It's kind of the universal problem that I have when doing this kind of work is we don't know how much data we need until we've sort of gotten into the problem.
Yeah. Hey, what's the biggest challenge to improve the performance of transfer learning models?
Well, transfer learning models still need some quality labeled data. They need less, but having that data is always a challenge.
Yeah. Hey, and next question, what is a minimal target data set size to make it suitable for transfer learning?
Yeah.
It is small, but...
Yeah, of course. So how little can you get away with? I think it depends on the problem and sort of the nuance of the problem. But I've seen in my own practice, I've seen transfer learning apply and get pretty good results from between a few hundred and a few thousand images.
Yeah. Hey, to what extent do you think machine learning systems will take over thinking tasks of humans?
Yeah, well, I think that for the foreseeable future, the things that humans do best, judgment and creativity, are going to stay being the jobs of you and I. I do think that in the near future, we're going to see the computer do more and more of the boring stuff for us.
Yeah. That's a nice dream. Hey, what does the future of machine learning look like, and what impact do you think it will have on society?
Right. Well, I mean, so I believe that software drives the world right now.
Yeah.
And I think that in the next 1 or 2 years, we're going to see all of that software that we use on a daily basis have machine learning integrated into it.
Yeah.
So it's going to become ubiquitous. Longer term, you know, there was a McKinsey study that says that there may be between 400 and 800 million jobs displaced by AI.
Yeah.
That may be true. You know, there's going to be some of that. I think that that's happened to us as the human. You know, that's happened to humans before. Every time we've come out okay, we've generated more jobs than we've displaced.
Yeah.
We'll probably be okay this time too if it continues in that trend. I hope it does.
I hope it too.
Me
Thank
too.
you so much.
You bet.
Thanks for watching, and if you like this video, go to the website of the Future Technologies Conference and you will find loads of other videos. Thank you, Mike.
Thank you.